All right, so now that you've found the model number and you may need to find some more information, well, obviously we've got data sheets available for our products online. Data sheets are a good place to go to just confirm, again, what you have. We're going to talk on a couple things here, but I want to show you our newer format we're rolling out here. It does include wiring diagrams and basic option code information down in the bottom right, and we're going to be implementing this on all of our products moving forward, so that should be very useful. As you can see down there in the bottom right, maybe tough to read on your screen, but we've got connector details, AJ, AF, ACK. Those, for those of you familiar with our load cells, know that would correlate to a screw type, bayonet type, or integral cable on those. Not in that order. All right. Looking in at the closer look at the data sheet here, we've got our model information across the top. I just wanted to highlight that we often have different capacities all under the same form factor. So, for example, the 1210 model is available in, let's say, 300, 500, 1K, 2K, 5K, and 10K capacities, all with the same form factor dimensions below that. Oftentimes customers don't realize that, so I just wanted to touch on that. And again, each one of those is going to have a full-scale output corresponding to the load cell for that capacity. And you can see as we jump over the 1220 now, we've got different capacities for that form factor. And then as we move over to the 1232, that's going to be for our 100K size. So, also on the data sheet, you'll be able to see performance data, as well as expected output, such as our 2.0 nominal, 2.0 or 4.0 on the majority of our capacities, millivolt per volt nominal output on there. Max excitation, that's also a good one to pick up on the data sheet, and also kind of what to expect as far as the zero balance goes. We're going to talk a little bit later about why that may be important to note. Other parameters such as safe overload, standard product is usually for 150% of capacity. That's something you need to make sure is appropriate for your application as well. And then there's connector information for the standard model, and also what cal data to expect. TNC is going to mean you're going to get both tension and compression cal data for that unit. Speaking of calibration, here's an example of a cal cert for a low profile. This is a 1210 model here, just like we talked about. ACK is going to refer to the bayonet connector, 10K, and then the dash B means it has a base on it. We're going to show you some pictures and talk a little bit about bases as well later on. But the load cell cal cert is going to have some good information with regards to how the unit was calibrated, how it performed, and also some information you can use for potential troubleshooting down the road if you need to, or for just, I would say, system health checks. So zooming in a little bit, again, we reference the model number, serial number. Bridge A is referenced there. If you have a multi-bridge sensor, meaning you have two connectors or two outputs, you'd have a separate sheet for the bridge B also. Below that, we've got some basic health information as recorded during calibration, test conditions, including the excitation voltage that's used during the calibration. Then below that, traceability information. So that's these items are basically what we were using here to calibrate the sensor, and we have full traceability in that regard there. Below that, we've got shunt calibration, and then performance summary, and the actual data for the calibration. Now, on the performance summary, we have both our rated output as well as SEB output, nonlinearity, hysteresis, and the SEB. So these are the parameters that we're holding the units to make sure they meet spec per the data sheet. And again, the data sheet values you saw earlier were nominal value, or excuse me, worst case values when it comes to performance. Typically, you're going to find an interface load cell performing at 2 times that spec. But important to note here again, SEB, you may see that and hear that. We've got more information online, but to take away, it's essentially the best fit straight line, taking the nonlinearity hysteresis into account for that unit. Backing up to the shunt cal data, this is useful to be able to check the load cell health at a future date. So we use a resistor on there. We shunt specific legs to simulate an output for either the tension or compression mode, and we record what that actual output is. This is something that you can usually utilize in your instrumentation later on down the road to just do a sanity check and make sure the load cell is still giving about the same output, which would be a good indicator of the health of the bridge. So again, CalCert's a great source for excitation, expected performance, as well as output. Again, you'll see a millivolt per volt output here, whereas if it's an amplified unit, you're probably going to see whatever the high-level output is on there.